imagine, if you will, the beginning.
The very beginning.
Yeah, the beginning. And I don't mean the polite, sanitized beginning you see in high school textbooks, with the tidy diagrams and the timeline perfectly spaced out across the page. I mean the reality of it.
Right.
The messy, gritty, incredibly chaotic reality of what scientists call the microscopic scramble.
You're talking about the primordial soup.
Exactly. The soup, but I mean, soup almost sounds too nice, right? Like something you have for lunch.
It invokes a warm, comforting image.
Right, which this absolutely was not. Picture a world of mud, volcanic vents spewing sulfur, lightning strikes hitting the ocean literally every second, and chemical sludge bubbling in the intense heat. It's a high-tempo, chaotic environment. It is noisy, and it is violent.
It is the prebiotic Earth, a place with a distinct, undeniable lack of order.
Completely. And the prevailing narrative, the one that has dominated the scientific landscape for over a century now, is that out of this squelching static, out of this absolute randomness, order just, well, it just emerged.
The idea is that if you shake the box long enough, eventually the pieces fall into place. That from the scramble of random mutations and chemical accidents, we got life.
It's the lucky accident theory.
Right.
The idea is that given enough time, the impossible becomes probable and the probable becomes inevitable. But today, we are taking a stack of research that challenges that narrative head-on.
And it challenges it aggressively.
Very. We are looking at a source text titled The Measured Verse. It's based on the work of J.R. Ahmed and several others in the fields of information theory and theology. And the mission for this deep dive is, well, it's a little different from what you might expect.
It is. Usually, when people challenge the lucky accident, they look for a designer who tinkers.
Right.
A sort of cosmic mechanic who steps in to manually fix things when the engine stalls out.
But we are going somewhere else entirely today. We aren't just looking for a tinkerer. We're unpacking the idea of a sovereign intelligence, a system so perfect, so measured, that it creates itself through laws that were written before the first cell ever divided.
It's the central conflict between the materialist view of unguided process and what the texts call the logic of creation.
So buckle up. We are going from the noise of the swamp to the silence of the cell and finally up to the stars. Let's get into it.
Let's start with what changed everything, the architecture of information.
Okay, yes, let's unpack this. Because for a long time, biology was just, it was biology, it was squishy.
It was wet.
Yeah, fluids and tissues and slime. Physics was the hard science with the heavy math. And biology was the descriptive science with the nice drawings of birds and plants. But then came the mid-20th century, and suddenly biology became an information science.
You're talking about the discovery of DNA.
I am, and I want to move beyond the metaphors we usually use here, because we always say things to you like, DNA is like a blueprint, or DNA is like a computer code.
It's a convenient shorthand.
It is, but the source material here is adamant. It is not like a code. It is a literal, quaternary digital system.
That's a crucial distinction to make. In computer science, we use binary, zeros and ones. Two options. It's a base 2 system.
Right.
DNA uses 4 chemical bases: adenine, thymine, guanine, and cytosine, ATGC. It is a base 4 system. And what's truly fascinating is that it functions exactly like a language or a computer code.
How else?
It has syntax, it has grammar, it literally has stop codes and start codes that tell the machinery when to begin reading and when to stop.
And that's just the software. But what blew my mind reading this is the hardware. The cell isn't just a blob of jelly. It's a high-tech manufacturing facility. You've got things like RNA polymerase,
Which acts essentially as a high-speed laser printer.
literally.
It zips along the DNA strand, reads the code, and transcribes it into RNA.
And then you've got ribosomes.
Translating hard drives.
Yeah.
They take that data, tape the RNA, and turn it into a physical product, which are proteins. They are literally reading coded instructions and manufacturing physical parts based on those instructions.
And here's where it gets really interesting. You know how when you're typing a text on your phone and autocorrect messes it up? Or I guess hopefully fixes it?
Sure.
The cell has error correction algorithms.
It absolutely has to. If the genetic code gets corrupted, the organism dies, or it mutates into something completely non-functional. So there are molecular machines that literally proofread the DNA during replication.
They just follow along behind the printer.
Exactly. They follow the polymerase, and if they spot a mismatch, like a wrong letter, in the sequence, they physically snip it out and replace it with the correct one.
It rivals the best spell check software we have today.
Actually, the source argues it's much better. The error rate is infinitesimally small because of these redundant systems.
And this brings us to bioinformatics. This is the field that treats biology purely as a data problem. The source makes a really profound point here. If DNA were just random chemistry, just a result of that primordial scramble, our software wouldn't work on it.
Right, because you can't parse noise.
Expand on that. What do you mean?
Well, biologists use tools like BLAST. That stands for Basic Local Alignment Search Tool. It searches genetic sequences exactly the same way Google searches text on the internet. It looks for patterns, syntax, and meaning. If I type random gibberish into Google, just mash the keyboard, I get 0 results. The algorithm cannot find meaning in pure chaos.
That makes sense.
The fact that we can read DNA like a language, search it, copy it, and edit it, proves structurally that it satisfies the mathematical definition of a language. It isn't just a molecule. It is a message.
So we have a digital code running on advanced hardware with error correction. The obvious question is, how did it get there?
And that is where the empiricist mindset steps in. We have to look at the cold math.
The cold mathematics. I love this part of the deep dive because it takes the emotion out of it. It takes the theology out of it temporarily. It's just numbers. And the numbers are staggering.
It's about quantifying the likelihood of chance. The baseline argument is that unguided processes, that chaotic scramble we started with, they are great at tearing information down.
Entropy.
Exactly, entropy. Things fall apart. Rust, decay, erosion. But unguided processes are terrible at building information up.
Let's talk about functional sequence space, which sounds like a dense sci-fi term, but it's actually really practical to picture.
Think of a combination lock. But instead of 3 little numbers dial, it has hundreds. And instead of one right combination, maybe there are a handful of right combinations that will open it.
But the vast, vast majority of combinations do absolutely nothing.
Right, or think of it like a library.
A library of books.
Imagine a massive library that contains every possible combination of letters. Most of the books would be utter gibberish, just random letters.
Like a cat walking across a keyboard.
Just noise. Only a tiny, tiny fraction of those books would contain actual English words, and an even smaller fraction would contain a coherent sentence. And a fraction of a fraction would contain a story that makes sense, that concept that is functional sequence space.
And how does that apply to biology?
In biology, most arrangements of amino acids are useless junk. They don't fold into a 3D shape. They don't do any mechanical work in the cell.
So finding a working protein isn't like finding a needle in a haystack.
It's like finding a specific atom in a haystack the size of the galaxy.
Let's run the numbers on this, because the source breaks down the math for just one single, relatively short protein. We are talking about a chain that is 150 amino acids long, which is not even a big protein by biological standards.
It's very modest. To get that specific protein by pure chance, you need 3 distinct things to happen simultaneously. First, you need the right sequence. You need the letters in the correct order so it means something.
Like getting the letters in a sentence right.
Exactly. The probability of getting that sequence and having it fold correctly into a usable shape is estimated at 1 in 10 to the 74th power.
Okay, 1 in 10 to the 74th, that's a 1 with 74 zeros behind it. That is already a number I can't really visualize, but we're not done.
We're not even close to done. Second, you need the chemical bonds to be right. They have to be what's called peptide bonds. Chemistry in a natural environment allows for several different types of bonds between these molecules, but life only uses peptide bonds.
And the probability of getting only peptide bonds in a chain of 150.
1 in 10 to the 35th power.
Okay. And there's a third hurdle.
Chirality. Handedness. This is honestly the weirdest part of the chemistry. In nature, molecules can be left-handed or right-handed. They are mirror images of each other, like a pair of gloves. When you synthesize them in a lab naturally, you get a roughly 50-50 mix.
Half left, half right.
Right. But life, biological life, only uses left-handed amino acids. Exclusively.
Wait, exclusive?
Exclusively. If you throw in a single right-handed amino acid into that chain of 150, the chain breaks. The protein will not fold. It becomes biological junk.
So what are the odds of getting 150 left-handed amino acids in a row by chance from a 50-50 mixture?
It's the same as flipping a coin and getting heads 150 times in a row. The probability is another 1 in 10 to the 45th power.
So to get our one single modest protein, We have 10 to the 74th multiplied by 10 to the 45th multiplied by 10 to the 45th.
Which gives us a total improbability of 10 to the 164th power.
10 to the 164th. A1, followed by 164 zeros. It's a number so big my brain physically refuses to hold it. It just becomes abstract math at that point.
It does. So let's make it concrete. This is where the mathematician William Dembski comes in. He introduced a concept called the universal probability bound, or the UPB.
The cosmological threshold.
Right. He asks a very simple, very profound question. What is the absolute maximum number of things that could possibly happen in our universe?
How do you even calculate that?
You take the number of atoms in the observable universe.
Which physicists estimate is about 10 to the 80th power.
Right. Then he multiplied that by the number of seconds that have passed since the Big Bang.
Which is roughly 10 to the 18th power seconds.
And then finally he multiplied that by the absolute fastest speed of any physical interaction. How fast can an atom physically transition from one state to another?
Planck time.
Exactly. Planck time,
Yeah.
the smallest measurable unit of time. And you got a final number.
10 to the 150th power.
10 to the 150th. That number represents the total probabilistic resource of the entire cosmos. It represents literally every single opportunity for any event to happen in the entire history of everything.
Okay, I see where this is going.
If an event has a probability lower than 1 in 10 to the 150th, it simply cannot happen by chance. It's a hard limit. There aren't enough seconds, there aren't enough atoms, and there aren't enough physical tries in the history of the universe to make it happen.
And the chance of getting our one single protein by random chemistry is 10 to the 164th.
Exactly. The mathematical rarity of one simple protein exceeds the total physical resources of the universe by 14 orders of magnitude. It's not just unlikely, it is mathematically, statistically impossible within the confines of our physical reality.
This is the moment when the math just steps in and says, no, you cannot have this for free.
And this leads us directly to what the source calls the explanatory filter.
Break that down for us because it's a great tool for thinking about this.
It's essentially a logic gate. When we observe a phenomenon, we pass it through this filter. First we ask, is it law? Meaning, does it happen out of physical necessity?
Like a crystal forming.
Exactly. A salt crystal forms a rigid, predictable structure because the chemical laws force it to. But DNA isn't repetitive like a crystal. It's irregular. It carries a sequence like text in a book. The laws of chemistry don't dictate the sequence of the letters. They just hold the letters together. So it's not law.
Okay, so then we ask the next question, is it chance?
And we just did the math on that. It grossly exceeds the universal probability bound, so it is definitively not chance.
Which leaves only one logical output.
Therefore, it must be design. It exhibits what we call complex specified information.
The source uses a really great analogy here to cement this, the election official.
I love this one. Imagine an election official in a small town is pulling names out of a hat to decide ballot order, just drawing slips of paper. And 40 out of 41 times, he pulls out the name of a Democrat.
And, surprise, surprise, the official happens to be a registered Democrat.
Right. We don't look at that outcome and say, wow, what a spectacular string of luck. We immediately infer design. We infer rigging.
Why? Mathematically.
Because it is complex, meaning the raw odds of pulling those specific names 40 times are astronomical. And it is specified, meaning the outcome matches an independent pattern, which is the official's known political bias.
And DNA fits that exact criteria.
Perfectly. It is statistically impossible, that's the complexity, and it performs a highly specific biological function, that's the specification.
So the math decisively points to a designer, but the biology points to something even more structural, more mechanical. We need to pivot and talk about the assembled engine.
This brings us to the argument of irreducible complexity.
I love this concept. It's the classic mousetrap argument, right?
It is. It's the most famous way to explain it. A standard wooden mousetrap has a base, a spring, a hammer, a catch, and a holding bar. 5 parts. If you take away the spring, you don't have a mousetrap that catches mice 80% of the time.
You don't have a trap that catches slightly slower mice.
No, you have a piece of wood with some junk on it. It catches 0 mice. The system works all at once, or it does not work at all. It is irreducibly complex.
And biological systems, cellular systems, operate exactly like that.
The bacterial flagellum is the absolute superstar of this specific argument.
The rotary motor.
It is a literal microscopic outboard motor embedded in the cell wall of certain bacteria. It spins at up to 100,000 revolutions per minute.
Which is insane.
And it can stop on a dime and reverse direction in a quarter of a turn.
And when you look at the biological schematics for this thing, and they really are schematics, it has a rotor, it has a stator, it has a bushing, a flexible universal joint, a propeller, a drive shaft. I mean, it looks like human engineering.
It requires about 40 different specific protein parts to build it. If you are missing the rotor, it doesn't spin. If you are missing the bushing, it physically falls apart. The argument from the empiricist side is, how could this possibly evolve gradually?
Right, because natural selection works by keeping random changes that offer a survival advantage.
But half a motor offers zero advantage. It doesn't spin. It's dead weight.
It's a drag, literally.
Yeah.
It uses up cellular energy and slows the bacteria down. Natural selection should actively weed it out, not preserve it.
So the logic follows that it must have arisen all at once, an assembled engine, fully formed.
But there's an even deeper layer of irreducible complexity here that the source points out. The chicken and egg of genetic translation.
This is the one that really keeps evolutionary biologists up at night. We established earlier that DNA codes for proteins.
Right. It's the instruction manual for building proteins.
But the microscopic machines that read the DNA, the polymerases and the ribosomes we talked about, those machines are made of proteins.
So wait, you need the DNA instructions to build the machine.
But you desperately need the machine to read the DNA instructions.
It's a perfect closed loop.
You cannot have one without the already existing presence of the other. It strictly implies a synchronous creation event. They had to arrive on the scene simultaneously.
Okay, so pause for a second. Let's look at where we are. We have built a formidable fortress here. The math says chance is impossible. The biology says gradual, step-by-step evolution doesn't work for these complex engines. We are standing right on the precipice of mathematically proving a designer who tinkers. But here is where the source material, the measured verse, takes a massive hard left turn.
It pivots entirely. And it pivots because of a severe theological and scientific danger.
The danger of the God of the gaps.
Yes. This is where the rationalist perspective steps in to critique the empiricist view of intelligent design. If we build our worldview or our philosophy purely on the things science cannot currently explain, we are building our house on shrinking ground.
Because if I confidently say to you, God exists because science cannot explain how the flagellum was built, what happens next year?
What happens when a scientist goes into the lab and actually finds a natural evolutionary explanation for it?
God gets smaller?
Exactly. If the divine only lives in the shadowy gaps of our scientific knowledge, then as the light of knowledge grows, the divine simply disappears. The source explicitly warns against this trap. It argues that we shouldn't be looking for miracles that break the physical laws.
We should be looking at the laws themselves.
Right. And this is where the scientific rebuttal comes in. The text actually plays devil's advocate, using the atheistic rejection to prove a higher point.
We need to talk about co-option, the scientific concept that nature recycles its parts.
Specifically regarding that bacterial flagellum we just spent so much time marveling at.
Yes. The type 3 secretion system. The T3SS.
I know. It sounds like a weapons system from Star Wars.
It does. But what is it?
It's a microscopic biological needle that certain bacteria use to inject toxins into host cells. Now, structurally, chemically, the T3SS looks almost exactly like the base of the bacterial flagellum.
It's literally the flagellum, just without the motor and propeller attached.
Exactly. It has the pump, it has the base mounting, but it doesn't spin.
So the materialist critique is, it is not irreducibly complex. Parts of it existed before as a completely different machine. Nature can and does repurpose things.
Nature is a scavenger. It co-ops parts that are lying around. It takes the toxic needle and, over time, turns it into an outboard motor. The unexplainable gap that the intelligent design proponents planted their flag in is closing.
So if the gap is closing, where does that leave this whole discussion? Did we just spend the first half of this deep dive debunking our own premise?
Not at all. We just cleared the stage for the actual real insight, the paradigm shift of the measured verse.
This is the part of the text that honestly gave me chills. It's a totally new way of framing the universe. The source talks heavily about moving away from blind faith and moving toward reason's lamp.
It references the traditional concept of taqlid, which means blind tradition or unthinking conformity, and it firmly rejects it. The text states that true faith, true iman, is not just blindly following what your ancestors told you. It must be born of mind and reason.
It demands intellectual rigor. We have to completely reject the assemble engine view, the idea of a creator popping into the universe to manually fix a missing pin in a bacteria, and instead we have to look for the immutable system,
This is the core concept of Sunnat Allah.
the way of God.
The central argument is this. The glory of a sovereign intelligence isn't found in intermittent tinkering. It isn't found in magic tricks or miracles that continually break the physical laws of the universe to get things to work.
Because, logically, if I invent a machine and I have to keep opening it up to tinker with it and bypass my own gears to keep it running, means I didn't design it right the first time.
Precisely. A truly sovereign intelligence would build a system so flawlessly perfect, so fundamentally robust, that it seamlessly creates itself from the ground up. The glory is in the law itself. The laws are self-operating, self-sustaining, and perfect from the moment of inception.
The source breaks this massive idea down by dividing reality into two distinct worlds, Alami Amar and Alami Akalk. Let's define those.
Alami Am is the world of command, the fiat, the decree of be, and this is the ultimate will of the Creator, and it exists entirely beyond human scope, beyond time, and beyond space.
It's the unapproachable origin point. And Alami Akalk.
That is the created world, the physical universe. This is the world of empirical science, and it is strictly bound by fixed, unyielding laws. Gravity, thermodynamics, electromagnetism, the strong and weak nuclear forces.
So the grand synthesis here is that DNA, with all its digital complexity, is not evidence of a creator stepping in to miraculously fix bad chemistry.
No. It is profound evidence that the foundational laws of chemistry were brilliantly designed to inevitably produce information from the very start.
That completely flips how we look at the flagellum debate.
It totally reorients it. Let's revisit that T3SS connection, the needle in the motor.
Right, the needle that naturally evolved into a rotary motor.
The atheist looks at that and says, see? No God needed, just natural co-option. The intelligent design proponent gets defensive and says, no, it's still too complex, God had to build it. But the rationalist, reading from the perspective of the measured verse, reframes the entire scenario.
How do they see it?
By asking a much better question. What kind of awe-inspiring universe allows a simple microscopic needle to organically become a complex rotary motor?
It points to the economy of divine laws.
Exactly. The fact that a needle can be seamlessly repurposed into a motor via natural selection doesn't disprove design. It proves the staggering efficiency of the underlying laws.
Yeah.
It proves that the biological parts are inherently modular.
They're like cosmic Lego bricks.
Yes. The laws are so efficient, so perfectly tuned, that functional precursors natively allow for immense complexity to build over time without requiring outside interference.
So the real design isn't just found in the final complex product. The design is in the process itself.
It's in the latent potential. The physical universe was fully loaded with the mathematical potential for the bacterial flagellum and the human brain from the very first millisecond of the Big Bang.
That is a much, much bigger idea than just a cosmic mechanic making a bacteria.
It is infinitely bigger. And it leads us directly to the concept of takdir.
Now, usually when people hear the word takdir, they translate it in English as destiny or fate.
Which carries a lot of baggage. But the linguistic root of the word implies measure or pattern.
So takdir isn't fatalism. It isn't a script where every action is forced and everything is pre-written.
No, it's the exact measure of the physical laws. The universe is the measured verse. From the fusion of stardust in a nebula to the twin helix of our DNA, everything follows a calibrated wisdom. Gravity is perfectly measured. The strong nuclear force is perfectly measured. If they were even slightly different, by a fraction of a percent, biological life simply wouldn't exist.
So the very reliability of empirical science, the fact that we can do an experiment twice and get the same result, that reliability is the takdir.
Yes. Because the laws absolutely do not change, we can study them. We can rely on them.
But this brings up a huge philosophical problem, which the text addresses, the human exception. If absolutely everything is law and everything is perfectly measured, are we just biological robots playing out chemical reactions?
The source addresses this tension head-on. It frames it as law versus choice.
Break that down. While the biological and physical world follows Sunnat Allah, inevitable, unbreakable law, humans are somehow unique in this framework.
We are what the text calls the active participant. We possess the unique spark of conscious choice.
We can choose to go against the flow of the universe.
Exactly. A rock obeys gravity. It has no say in the matter. A cell divides based on chemical triggers. It has no choice. But a human being, we have agency. We can choose whether or not to align ourselves with the moral law.
And just as gravity is a fixed physical law for matter, the source argues that justice is the fixed immutable law for the human soul.
Think about the consequences. If you step off a roof and ignore the law of gravity, you get physically destroyed. If you ignore the law of justice, human society gets destroyed. The breakdown is just as inevitable, even if it takes longer to see.
So this intricately connects the strict biological order we see in the cell to the social order we need in society.
It does. The logic of creation demands a human society bound by comradeship, equity, and reason, not by oppression and chaos. Because we are the only beings capable of intellectually understanding the measure of the universe, we are the only ones capable of intentionally implementing its justice.
That is a very heavy responsibility.
It is the ultimate burden of consciousness.
So let's pull all these threads together and wrap this up. We have journeyed from the chaotic primordial soup to the highly structured digital code of life. We've waded through the mathematically impossible odds, looked at the irreducible rotary motors, and finally arrived at the immutable laws of the universe itself.
It's been quite a conceptual journey.
The final synthesis of this text seems to be a harmonious middle ground. The empiricist appreciates the cold math, because the numbers, the 10 to the 164th power, they don't lie.
And the rationalist appreciates the profound, self-sustaining law behind that math.
The ultimate message of the measured verse is not to frantically look for magic in the gaps of our knowledge.
No, it is to place profound trust in the system itself, to trust the sovereign intelligence of a universe that organically, inevitably self-organizes.
The source mentions two final anchoring terms right at the end, Kabdila and Tawila.
These refer to the nature of the cosmic laws. The laws themselves do not change, that is Tabdila, and their specific application does not arbitrarily shift, that is Tawila,
They are absolute constants.
which means the universe is deeply faithful to its own design.
And that leads me to a final, somewhat provocative thought for you listening to this, to mull over on your own time.
Go for it. Let's hear it.
If the universe truly is a measured verse, if it is a masterpiece written in the precise ink of DNA and unyielding physical law, and if we, as conscious humans, are the only readers currently capable of understanding the syntax of that language,
The only ones who can peer through a microscope and actually crack the code.
does that make the act of scientific discovery, the actual process of doing science, the ultimate form of worship?
You know, I think the authors of the source material would give a resounding yes to that. To carefully read the verse is to intimately know the author.
It is something profound to think about. But that is all the time we have for this deep dive.
Keep reading.
And always keep questioning.